All right, number two. Uh, this is an integral problem where we're going to use U substitution, and there'll be a number of changes here that are a little bit more complicated than some of the earlier U substitutions we've seen. All right, let's get started. I'm going to choose x squared plus 9 to be U. And I'm going to take a little, I'll go through this, explain what I'm doing. It'll be more sense when I've finished and go back and look at the pieces that I've created and how they relate to each other. So U equals x squared plus 9. And if I take the derivative of that, du would equal 2x. Okay? And if I want to think in terms of what are these limits in the context of U, what would U of 4 be? Well, that would be equal to 4 squared plus 9. That's 16 plus 9, that's 25. And U of 0 would equal 0 squared plus 9, that's going to equal 9. Okay. And I'm going to do one more thing, and you'll see why in a moment. I'm going to add a 2 here, multiply that by 2, and also multiply it by 1/2. Well, multiplying by 1/2 times 2 is effectively multiplying by 1, which has no change in the value. But then I'm going to go ahead and move this 1/2 outside of the integrand. And now all of a sudden I have a very powerful rewrite. This is U to the 1/2. This is du. I'm allowed to put the do in here because I got the 1/2 outside here. So it's 1/2 of this integral. So this integral is a little bit different. But because of the 1/2 and the 2, it's got the same exact numerical value as the original version. Okay. Now let's see what happens. I'm going to go ahead now and rewrite all of this as a new and different integral. I'm going to say this equals 1/2, the integral, no longer from 0 to 4, but now from 9 to 25. And this is 1 over u, okay? But basically 1 over the square root of u, or 1 over u to the 1/2, okay? du. Okay, so take a look at this now. This is u, the square root of u, or u to the 1/2. This is u to the 1/2, all right? 2x was the derivative of u, so this is du. So I have 1 over u to the 1/2 times du, okay? And in order to arrive at this du, which was 2 times x, I did have to go ahead and add a 2, but I offset that with a half out here. And because I'm doing everything now in terms of u rather than x squared plus 9, I had to change the limits. But if you think about it, when I plugged a 4 inside of here, I add the square root of 25. When I plug 25 into here, I have the square root of 25. When I plug 0 in here, I had the square root of 9. And I plug this in here, I still have the square root of 9. So this is exactly the same as this. All right, now, but this is much easier to work with, especially when I make one more little change. We'll call this 1/2 integral from 9 to 25 of u to the negative 1/2 du. And the reason I'm doing that, now I can go ahead and apply the reverse power rule in a very easy way. Reverse power rule, I take this exponent, raise it by 1 up to 1/2, and then divide by 1/2. But instead of dividing by 1/2, I'll multiply by the reciprocal. I'll multiply by 2. So let's see what that looks like. So this is going to equal 1/2 times u to the 1/2 divided by 1/2, or times 2. And I'm going to look at this from 9 to 25. Evaluate from 9 to 25. Okay. And then I can go ahead and clean up the 1/2 from the 2 here. So my arithmetic is much easier. This equals u to the 1/2 from 9 to 25. Okay. So that's going to equal basically 25 to the 1/2 minus 9 to the 1/2. That's going to equal 5 minus 3 is going to equal 2. There's our answer.